Assalamu alaikum everyone. So this is the final topic on AC voltage controller that is called Cyclo Converter. So Cyclo Converter is a kind of converter that actually is used to convert the frequency. Okay, so a device which converts the input power at one frequency to output power at a different frequency with one stage conversion is called Cyclo Converter. So here we are not controlling the voltage, rather we are controlling the frequency of the input power. So it's the AC-AC conversion and only changing the frequency. It can be of step up Cyclo Converter, it can be step down Cyclo Converter. That means where the output frequency or F out is higher than the source frequency Fs, that is called the step up Cyclo Converter. And if we have our F out, the frequency of the output is less than the frequency of the source, then we call it step down Cyclo Converter. We can differentiate cyclo converters based on the based on whether it's a single phase or three phase cyclo converter. So the main purpose of the cyclo converter is to control the frequency or to change the frequency. Now where we actually need this control of frequency, so we normally if we need to control the speed of the induction motor, if we for instance in escalators or in power ratings, in driving mine hoists, rolling mills, ore processing, owned rotor induction motors, and application like this, cyclo converters are very useful. And normally the power ratings of these converters ranges from few megawatts up to several tens of megawatts. Another important area of application of this frequency conversion is actually in the electric tractions. That means in the electric trains in Europe, the frequency of this system is 16.33 Hertz. Sorry, 16.66 Hertz. It is exactly 1/3 of the power frequency in Europe. It is 50 Hertz the power frequency, and the frequency in the electric train lines is actually 16.66 Hertz, exactly 1/3 of the frequency that is being used in the power frequency. In the US, this is 25 Hertz, the electric traction applications. So in those areas, in electric tractions, it is useful to have cyclo converters, because if you need to connect it to the power grid, and after that you need to have a frequency conversions where you basically change the frequency using a cyclo converter that can be used in the electric tractions. So let's see the operation of single phase cyclo converter, how this is actually operating. So here on the right hand side, right top corner of the side, it shows the circuit, and if you look at here, we have two parts. One is P converter and the other is the N converter, and we have the load connected here. So if we want to have a step down operation in the cyclo converter, that means the output frequency is higher than the input frequency, then we can do that by this. So during the positive half cycle, so this part is positive and this part is negative, during this time the current is flown like this using the thyristor T1. Current flows and it enters the load from the top, it flows through the load, and then it leaves through T2 during the positive half cycle. So during this time, and during the negative half cycle, so during the negative half cycle of the input voltage, when the polarity changes, this part becomes positive, this part becomes negative, and at that time if I change it to a different color, at the time the current is actually flowing like this. It goes here and then it again enters from the top and then leaves the load like this. So you see that the output voltage, so this is the output, so the output voltage is like this. So depending on the frequency that we want, in this particular example the output frequency is 3 times smaller than the input frequency, so it's 1/3 of the input frequency. So that means that the first 3 half cycle we want to have the output in the same polarity. So in the first 3 half cycles only the P converter will operate, and by operating P converters we have the current flow always from the top. That means that the polarity of the output voltage is positive in this particular case. So up to 3 half cycles this P converter is on, and after 3 half cycles we will turn these thyristors off because we will not apply any gate pulse here. Instead we will apply the gate pulses on the N converter. So during that time, let's change the color again here. So our polarity here is positive again. So this is positive, this is negative. So when this is positive the current is flowing like this, and then it comes here and then it goes through T1 prime, and then now it enters from the bottom end of the load and then it leaves like this. So your output is now negative, so your output is this part. And when the polarity changes here, so the polarity changes positive and negative here, and during that time your current flow is like this. It goes here and then it enters through T3 prime, and then it enters the load from the bottom terminal, and then it leaves using T4. So it leaves using T4 here. So that means that the output voltage is again negative here. So you can have for a input voltage like this, the output voltage you can have something like this in the output, and of course you can control the firing angle of the thyristor alpha and to control the amplitude as well. So eventually if you filter out the harmonics part of this circuit, then this can be the fundamental component can be like this. So but you have also the harmonics associated here, so you have to take out the harmonics using the filters. So by using appropriate filters you can remove the harmonic contents. So on the left hand side here it shows the, if you need to have a frequency of which is half of the input frequency, then you can turn this P converter on for 2 half cycle and then use N converters for 2 half cycles like this. If you want to make the output frequency 1/4 of the input frequency, then you can correspondingly turn on the P converter for 4 half cycles and then turn on the N converter for 4 half cycles and repeat the operations depending on the output frequency you need. But remember again that this is of course not sinusoidal, but if you do the Fourier analysis you will see that there is a fundamental component which will carry most of these currents or most of the voltage, and then you have some other harmonic frequencies, other harmonic contents in the voltage that you have to filter out. So using appropriate filter design you can have in the output have a AC voltage with a lower frequency than the input frequency in this particular arrangement. Now in the step up operation of the cyclo converter, what you can do is that instead of so in the step down operation what you did is that you allowed your P converter to be on for both positive and the negative half cycle, But now within the first half cycle, within the positive half cycle or within the negative half cycle, you will turn on your P converter and N converter one after another. So in this particular case, you first allow your P converter to be turned on, so that is why your output is following the input for the time until T1, and after that you are actually turning on your N converter, so that is why you get the negative voltage in the load, and you turn on your P converter again and your N converter again. So you have actually 4 times than the input frequency. As in the output you have 4 times the input frequency. But of course, again, if you look at here, you have other harmonic components in this arrangement, so that's, you have to take it out. You have to remove the harmonic components using appropriate filters to get a more sinusoidal kind of wave shapes in the output. So you can do both the step up and step down operation in the frequency using cyclo converter or power electronic devices. Now this is example of 3-phase cyclo converters. So in the 3-phase arrangement, you have 3 phases connected here, the load is here, and you are basically, you have your phase VAB here, BC here, VCA here, and the concept is the same. So you have to turn the P converter on, that means the first part is your P converter, so you have to turn this on to have the output, to have positive voltage in the output, and you turn on your N converter depending on the frequency that you need. So you will decide how long you need to keep these things on. Depending on that, you will turn on your N converter, and your output voltage, you will get the output voltage like this. So that's it for the cyclo converter. If I summarize it, if I summarize the cyclo converter, then cyclo converter is basically needed when you need to do the frequency conversions, and normally we need these frequency conversions when you need to change the speed of the induction motor, or when you need to change the frequency for electric traction applications, or in the mining applications where in the electrical machines this full load operation of these induction motors, this can be controlled by changing the frequencies. So at the starting time, if you can, when you start the motors, if you change the frequencies, you can control the starting of the induction motor for a full load operation. Or so depending on our need, in many applications we may have to change the frequency, and cyclo converter is the device that is actually used to control the frequency. And we have step down and step up operation of the cyclo converters, and we have seen single phase and 3-phase arrangements operation of the cyclo converters. So that is it. If you have any question, we will address it in the discussion class. Thank you.